Okay, good morning, good afternoon, or good evening, whatever the case may be. This video here is going to cover section P-5 in pre-calculus class, and it's just a review topic you've seen before, factoring polynomials. This will probably be the last time you're formally taught factoring, at least in the high school setting. So here we got our objectives for this section. We're going to factor out greatest common factors. We will factor by grouping. We will factor trinomials, factor the difference of two squares, factor perfect square trinomials, factor the sum or difference of two cubes, come up with a general strategy to factor polynomials. And the last one down there, factor algebraic expressions containing fractional and negative exponents. I don't know if you touched on that in college algebra last year or not. That might be new to some of you. But today we're going to start off with the easy stuff. So here we go. No warm up here. First little example here. What is factoring? We're going to, if something we can break it down into two multiplied terms. Those two multiplied terms are factors of the original expression. So here we see 10x squared plus 15x. There's a plus sign in between those terms. So it's a sum of two monomials. Here we can factor out of the numbers, we can factor out a 5. It's common to 10 and 15. We can also factor out one of these x's since each of those terms has an x. So we factor out the 5x, and what's left inside the grouping symbols there is the 2x plus 3. This is just the reverse of the distributive property. We're undistributing. So the first one here isn't too bad. Letter A. If I look at just the numbers, I got an 18 and a 27. Well, if I can factor a common number out of both of those, it would be a 9. So I can pull a 9 out of there. And I'm going to have something left in the grouping symbols. And I should have left myself a little more room, because we also have some variables. Here's x to the third and x to the second. Now, we can factor out the lesser of those. Here we have an x times an x. Here's 3 of them. So we can factor out an x squared. So let's see what's left inside here. We can either do it as division or sort of fill in the blank. If we were going to distribute, we'd multiply this 9 by something. 9 times something is 18. Or you could do this 18 divided by 9. 18 divided by 9 is 2. And then we had an x to the third, but we factored out an x squared, so there's a 1x remaining in there. And then we have our plus sign. The 27, well, 9 times what would be 27, or 27 divided by 9 would be a 3. And the x squared was factored out in its entirety. So there's nothing left here attached to the 3. There could be a 1 there, sort of as a placeholder, but we really don't need it because we have the 3. So to make it look a little better, our answer 9x squared times the quantity 2x plus 3. If you're not sure you did everything right, we can always distribute and check our work. 9x squared times 2x, that's 18x to the third. And 9x squared times 3, 9 times 3 is 27, and then the x squared is attached. Now letter B is a little different. In letter A, we only had one plus or minus sign to separate our terms. Here it looks like we've got 3 plus signs, but let's be careful. Here's a plus sign in between, and the other plus signs are part of a term. This is an x plus 3 term, and this is the exact same x plus 3 term. So this red plus is really what's separating our big terms. For me, this makes a little more sense if I put a set of brackets around the whole thing. We want to factor stuff outside of these brackets. So this is a term. I'll underline it here in black. And then in blue, here's another term. So what is in each term that we can factor out? Well, there's an x squared here, but there's no x or x squared here. Here we have a 5. Over here is just a 1. So we can't do anything with the x squared and the 5, but we do have an x plus 3. This is getting a little sloppy here. We do have this x plus 3 that's common on each side of this plus. So if we factor out an x plus 3 term, let's keep it in its parenthesis because it's still a term, what would we be left with inside? This x squared and a plus 5. And we could check, just like we did in part A, by distribution. If we were to distribute, we would have x squared times this x plus 3 term. Oh yeah, we're distributing this as a quantity in its parenthesis. So let me put that in sort of red parenthesis here. We distribute this quantity x plus 3 is going to be multiplied by the x squared times x plus 3. And then we're going to have this 5 right here times that same quantity, x plus 3. Okay, on to the next slide. Example 2, factor by groups. Usually when we're factoring these quadratics, it's a 3-termer. Usually you have some number and an x squared, plus or minus some other number with an x, plus or minus some constant at the end. In this case, we have 4 terms, and the leading term is not an x squared, it's an x cubed. So look in the directions for the distinction factor by grouping method, or if you got 4 terms and the leading term is a third power, it might be a factor by groups. And to factor by groups, we're going to just sort of group off these first 2 terms. I'll do it in a set of blue parentheses. And the second 2 terms we'll factor off. I'll do here in a set of red parentheses. Now this is a good one. This sign right here I sort of hit with the red parentheses. That's a plus. So if that's a minus, we might have to be careful factoring out a negative. But in this case, we don't have to worry too much. In the blue parenthesis, x cubed and 4x squared, we can pull out an x squared. Left in the first term, if we pull out an x squared, will be an x, and then we have our plus, and we pulled out that x squared, so there's a 4 there, x plus 4. And now here, our next term in red, 3x and a plus 12. Well, we can factor out a 3 times, and when we factor it out, we're just left with an x there. Factor a 3 out of 12, and you're left with a 4. Now, the key here, to keep this problem going, now it looks like example 1, part B. Here's an x plus 4 term that's common on both sides of this plus. So if I put a set of brackets around that, and we pull out that x plus 4 term, it comes outside as x plus 4. And then what's left inside is our x squared and a plus 3. X squared plus 3. And it's factored by grouping. Be careful, if we could go farther in here, if this was like x squared minus another square, something we might be able to factor it farther. But a squared term and a plus, we're not going to be able to factor that anymore. Here's one for you to try on your own. If you're watching this on video, you can pause the video and then try this one factor by groups, and then start the video back up and see if you got it right. All right, factor by groups. I'm going to sort of chunk those 2 off together, and I can pull out an x squared, and I'm left here with an x and a plus 5, x plus 5. Now here's where I warn we got a minus in there. So we got to be careful. I'm going to factor out a negative 2. So I'm going to pull out a negative 2, and then that's going to leave this as an x. Now here, this sign is going to switch. We factored a negative out of that negative. So that's going to change to a plus, and we factored a 2 out, so that 10 is going to turn into a 5. If you're working on one of these problems, and these factors have a different sign in the middle, a plus 5, and if we accidentally had a minus 5 in here, that is the most common mistake in factor by grouping. These terms in a factor by grouping should turn out to be the same, so the problem can continue. If you get a sign off, go back and double check your work. Be cautious about that minus. All right, we have an x plus 5 in parenthesis, so that is a common term. We'll pull out the x plus 5, and then we're left with this x squared and a minus 2. X squared minus 2. Problem solved. Now here, a little strategy about factoring trinomials. It says to factor a trinomial in this form, ax squared plus bx plus c, a little trial and error might be necessary. I've seen a lot of students are getting more into this, the ACB method, ACB, breaking the middle term up and turning it into like sort of a factor by grouping. I've seen students that are much better at that than I am. I have not had that much practice with the ACB method. So here's how I sort of learned it and how it's presented in the book. This first term, ax squared, it has to be from x times x. If that a is a 1, it makes it so much easier. So that's just going to be x times x. And then you want to find 2 numbers that multiply to c that add up to the b value in the middle, the outers and the inners. Again, being this is pre-calc, you've seen this factoring stuff quite a few times. So let's just dive into an example here. Factoring a trinomial, leading coefficient is 1. 1x squared plus 6x plus 8. Again, a little trial and error, and the more you do these, they do get easier and easier. I encourage my students that we're going to set up an empty set of parentheses down here, 2 factors. We need an x squared. The only way to get x squared is x times x. Now this is nice because this is a plus and this is a plus. We're rest assured that these are positives also. Now at the end here, our c value is 8. 8. So if we think out how to what factors are there buried in 8? Well, 1 times 8 is 8. 2 times 4 is 8. 3 doesn't work, and then we get back to 4, so it's just this one reversed. So I want to look across these rows, and I want two numbers that add up to 6. Well, 1 plus 8 is 9. 2 plus 4 is 6. That's our middle term, 2 and 4. So x times x, that's our x squared at the front. The 2 times 4, that's the 8 at the end. And if we add up the plus 2 and the plus 4, we get the plus 6 in the middle. Again, it's not bad when the leading coefficient's 1. It works out nice most of the time. Here's another one. Leading coefficient is 1. So I'm just going to set up some parentheses. X squared has to come from x times x. Now here we got a plus and a minus, so we're not sure what the signs are going to be. We're going to have to be careful here. I'm going to do a little factor t of 18. How do we multiply to get 18? 1 times 18, 2 times 9 work, 3 times 6, 4 doesn't work, 5 doesn't work. We get back to 6, and these are just reversed. So now the signs, remember this is a negative 18. So pluses or minuses could go to either one of these. One's going to be positive and one's going to be negative. We want two of them that add up to 3. Well, these are, if we add these together or subtract them, these are 17 apart on a number line. These two are 7 apart on a number line. These ones are only 3 apart. So we can add or subtract these and get the positive 3 we want. Since we want a positive 3, we want the bigger number to be positive. Positive 6 and negative 3. Positive 6, negative 3. And just to check our work, x times x, that's x squared at the front. 6 and negative 3 is negative 18 at the end. And if we add those numbers together, 6 and negative 3 add up to 3x in the middle. Just some practice problems here. Again, in the class, we call this the team huddle. So you can pause the video and then factor these, start the video back up, check your answers with mine here on the video to see if you got them right. Enjoy. Okay, let's do these in little groups here. Okay, the first one, when I look at that across, I see 9, 18, and 27. Those are all divisible by 9, so we are going to factor out a 9. And then we got x to the 4th, x to the 3rd, x squared. We can factor out the smallest, that's x squared. So let's see what's left inside. We factored out the 9, so there's a 1 there. We factored out an x squared, so there's an x squared left of that x to the 4th. And then we got minus 18 divided by 9 is 2. We factored out an x squared, so there's an x there. And the last term, it was a 27. We factored out 9, so that's a plus 3. And we factored out the x squared entirely. Now, can we keep going? Here's 9x squared. I look at this, x squared minus 2x plus 3. Let me switch to red ink. So x squared is x times x. The only way to factor 3 is 1 times 3. So if I make my 3 and 1 in there, to get a minus 2 in the middle, it would have to be a minus 3 and a plus 1. So there it looks like we got it fully factored. Number 7 below that, I see an x plus 5 and an x plus 5 on either side of this plus. So we will pull out this x plus 5 term, and we're left with this x and a plus 3. X plus 3. All righty, having fun. Number 11. These look like factor by groups. I see 4 terms. Leading term is a cube. So if I group off these two, I can factor out an x squared, leaving an x minus 2. plus, let me switch to blue ink. Here we're going to factor out a 5, leaving a 2x minus, or an, oh, excuse me, x minus 2. And again, they match up nice. So we can pull out that x minus 2 term, leaving us x squared plus 5. And that's as far as that one goes. 13 is also factor by groups. First two here, we can pull out an x squared, and that'll leave there an x minus 1. These here, we can also factor out a 2, leaving x minus 1. So the common term x minus 1 can be factored out, leaving us with this term x squared plus 2. X squared plus 2. All right. Just a couple more to go, 17 and 19. And these are just leading coefficient of 1. Again, if you want to do the ACB method, if that's what you're comfy with, by all means, I'm only interested in the correct answer. I really don't care how you got there, what method you used. So let's see this first one here. X squared has to come from x times x. Everything is positive, so these will be positive. Two numbers that multiply to 6, 6 times 1 or 2 times 3, and I want those numbers to add up to 5. So plus 2, plus 3. Remember, they have to be positive. If the 1 was negative, we could get that 6 and a minus 1 to add up to 5, but we need both of these to be positive because they do multiply to a positive 6. And the last one, number 19. Empty parenthesis, x squared comes from x times x. And then the factors of negative 15. 1 times 15, that's an ugly 5. 2 doesn't work. 3 times 5 works. 4 doesn't work. And then we're back to 5, so these would just be reversed. I want to add them up and get a negative 2 in the middle. So that'll be a minus 5 and a plus 3. Minus 5 plus 3. Okay, I think that's our last example and practice problems. Ooh, no. We got here example 5. Oh yeah, this is a little longer than I remember. That's no problem, more fun. And you can always pause the video and take a break anytime you want. Here we go, example 5. Now, if the leading term is not a 1, they can sometimes get a little tricky. You need a little more trial and error. Or here, this is where I really should work on my factor by grouping, or excuse me, my ACB method, because these are where the ACB method really does shine. I'm going to kind of do it old school, though. I got here at the end, negative 3. That's an easy one. 3 is prime. So this term here has to be a 3 and a 1, but it's either positive or negative. We don't know. The trouble with these comes from the leading term, 8. In this case, 8 is 1 times 8 or 2 times 4. And then also those reversed. So here is where I got so good at this when I was in school, all the trial and error and practice. I know that I'm going to have an x and an x here, but I could put my 2 first and my 4 second, or I could reverse those. I could have a plus 3 and a minus 1, or a minus 3 and a plus 1. So the way I started working on these, I know my leading term, the 2x and the 4x, will give me the 8x squared, and my 3 and my 1 will give me the minus 3 at the end. So if we do it this way, 2x times 1 is 2x, and 3x times, or 3 times 4x is 12x. Can I add, oh, and I hit the nail on the head. This was completely by accident because I'm not looking at my notes right now. We do need a negative 10 in the middle. Can I assign a positive and negative to these to get them to add up to negative 10? Well, if I make that a negative 12, and if I make that a positive 2, it will work out to be a negative 10. So when I multiply these outers, I want to get this negative 12x. So I want this to be a minus 1. And I want a positive 2x here, so this will be a positive. Because these signs are definitely going to be opposite. If this is a minus, this has to be a plus to get the minus here at the end. And I'm just going to double check my work here. Again, first term times first, 2x and 4x is 8x squared. My outers now are a minus 2x. My inners are a plus 12x. That does add up to Ooh, now hold on. Did I get that backwards? Oh, yeah, I do have my signs backwards. You were probably yelling at your screen. That should be a +1 and a -2. Or excuse me, +1 and a -3. So now my outers, yeah, there it is. My outers are the positive 2x, and my inners, the -3 and the +4, that's my -12x. And if I add those up, we get the -10 in the middle. Now, I just remembered here, down in the bottom, I'm going to pull this up. Here's all the variations you could have tried before you tried the correct one. So the first batch they go through are the 8x and x. 8 times 1 is 8. So here are all the scenarios with an 8x and an x and a 1 and a 3 where they switch around the pluses and the minus. If you FOIL them out, or if you work out that the middle term, you're getting all kinds of different stuff here. Here's where they find the good one. You know, our terms 4x plus 1 and the 2x minus 3 does give us the negative 10x in the middle. If we move around the 4 and the 2, or the plus and the minus, we get all these different middle terms, positive 10, negative and positive 2. So it was, you know, it's a good trial and error thing. Again, this is where the ACB method really does show its its uses, I guess you could say. Now on to easier stuff here. This might be my favorite ones to factor. Difference of two squares. And here they write it out like this. If you have some number a squared minus b squared, that will always factor down into a sum and a difference, a plus and a minus. And your factors are going to be a and b, an a plus b and an a minus b. It says here in words, the difference of the squares of two terms factored as the product of the sum and the difference of those terms. You know, this is a squared, so that term is a. Here's b squared, that term is b. So when we, and this always has to be a minus. That will always be a sum and a difference of those terms, the a and the b terms. These usually stick out like a sore thumb. The directions will say factor the difference of two squares, or you'll see a perfect square minus another perfect square. X squared is a perfect square, 4 is a perfect square. Same thing, let's just do a first. A is a nice and easy one. So we could sort of think about it like this. What would you square to get x squared? Well, that would just be x minus. What would you square to get 4? 2. So your terms are x and 2. And your factors then will then be a sum, x plus 2, as well as a difference, x minus 2, those multiplied together. If we multiply the first times first, there's our x squared. Last times last is the minus 4. And if we FOIL it out all the way, the outers would be a minus 2 and the inners are a plus 2, so they would cancel each other out. And we never have a middle term in these difference of two squares. And that's another way these sort of stick out. There's only two terms to them. The first term will be something squared, and then minus another something squared. Now, B looks a little more intimidating because we got some big numbers in there, but don't let it fool you. Always be looking for those perfect squares. 81 is a perfect square, so is 49. And let's write it like this. What would you square to get 81x squared? Well, the square root of 81 is 9. The square root of x squared is x. So that term is a 9x. The 49 is a little easier. What's the square root of 49? 7. So your terms are a 9x and a 7. So your factors are going to be a 9x plus 7 multiplied by a 9x minus 7, a sum and a difference of those same terms. Now here, example 8, it says a repeated factorization. So if you think the problem's over, it might not be done yet. So let's see here, x to the 4th. Well, that is a perfect square. What do you square to get x to the 4th power? That would be x squared squared. Remember, here's where you multiply exponents together. Squared to its own power, that would give us our 4th power. And then 81, that's a 9. So let's see here. We're going to have two factors, an x squared plus 9 and an x squared minus 9. So x squared plus 9, x squared minus 9. Now here's where you might think, okay, the problem's over. I've factored it. And the first term, that's true. This x squared plus 9 can be factored no farther. But this x squared minus 9 can be. X squared is a perfect square, x times x. 9 is a perfect square, positive 3, negative 3. There we go. Now it's fully factored. It was repeated. We did it once, and we had to do it one more time to get it down to all its factors. Now, another one here, a perfect square trinomials. These can be tricky. Always be looking for the directions. In the exercises, I believe on the worksheet, the directions will have these problems separated, and it will say these are perfect square trinomials. So it says here, let a and b be real numbers, blah, 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 blah. So here we've got a squared. That's just going to be some variable, usually x. And then here's 2ab plus b squared. Now, if they tell you, if you're sure it's a perfect square trinomial, here's how I teach my students how to do this. You're just going to take this a squared and square root it. That'll just be an a. Whatever this sign is, bring it down. In this case, it's a plus. And then b squared, what's the square root of b squared? B. So this is going to be a plus b quantity squared. We're going to square that out as a quantity. Now over here for the other one, they just put a minus in there. A squared minus 2ab plus b squared. You're still going to set up a perfect square binomial. It's some quantity squared. Well, this is a squared. Bring it down as just an a. Since that's a minus, bring down the minus, or like over here we did with a plus. And the b squared, square root of that is just b. A minus b quantity squared. So if we do FOIL this out, that's where we wind up with the middle terms. So here the first one's not bad. If you did not know this was a perfect square trinomial, you could just do this by the ACB method or just trial and error. But since they do say here it is a perfect square trinomial, we know that it's going to be some quantity squared. Well, x squared, just bring down the x. This is a plus, bring it down. What's the square root of 9? 3. X plus 3, quantity squared. If we were to FOIL that out, or just write it twice and FOIL it, yeah, x plus 3 times x plus 3, the middle term would be the outers would be a 3x, and the inners would be another 3x, and if you add those up, you get the 6x. Now, letter B, I'm very glad they told us that this is a perfect square trinomial because I know it's going to be something like this, quantity squared. What is the square root of 25? 5. Square root of x squared? X. Bring down the sign. In this case, it's a minus. What's the square root of 36? 6. And another way we can check that middle term, if I click back to this slide, it's 2 times a times b. 2 times a times b. So if I multiply 5x times 6, I get 30x. And if I multiply that by 2, I get the minus 60 in the middle. So the middle term does check out, even though I'm sure it was going to because they did tell us it was a perfect square trinomial. All right, these are your practice problems. I believe this is the end of the lesson. Yeah. So the first batch, the leading term is not a 1. So, try this with the ACB method or a little trial and error. I did clip the directions here. This is a perfect square trinomial. So this one is perfect square trinomial. This one will work out just nice. And these are difference of squares, a square minus a square. So again, pause the video, try the problems out, and then fire the video back up. See if you got them right. Okay. Okay, the first one here, I'm going to set up some empty parentheses. The 6x squared, you could do 6 times 1 or 2 times 3. Here it's going to be 2 times 3. I got a 2x and a 3x. And I need a couple numbers here that multiply to positive 12. And that's going to be a negative 3 and a negative 4. Again, now you might have done this by the ACB method. You break that middle term up and then do a factor by grouping. The method doesn't matter. You should have got to this same final answer that I got. Number 30, 8x squared. In this case, the 8x is going to, or 8x squared is going to be an 8x times an x. And then the 4 is going to be a plus 1 and a plus 4. The 8x has the plus 1, and then the single x has the plus 4. So then our outers would be a 32, one more in the middle, that's 33 in the middle. And again, factor by the ACB method is absolutely fine. Let's do these in order. There's 40, 42. We'll save that one for last. These are nice. Again, one of my favorites. Difference of squares. It's a squared term minus another squared term. So my terms are x and whatever the square root of 144 is, 12. So one of those will be a plus 12 and one will be a minus 12. We'll FOIL it out. The middle terms cancel. The last one, or no, this is the second one here, the square root of 64 is 8. So that's 8 times 8. X squared comes from x times x. And then we got an 81. Square root of 81 is 9. So there's our terms. One of them is a sum. The other is a difference. Now again, the last one, this might be tricky if the directions, if I didn't clue you in, that this is a perfect square trinomial. Again, in the homework, look for that right in the directions. If it says factor this perfect square trinomial, you know your answer is going to look like this, some binomial squared. Well, what's the square root of 9 and x squared? Well, that'll be a 3x. We bring down the middle term sign, that's a minus. And then what's the square root of 1? 1. And that should be it. Okay, the homework for this is a worksheet. Either you got a hard copy of that in class or it will be somewhere on Microsoft Teams or something like that. It's just a worksheet. So have fun with that, and I'll see you in the next video.